screen. So like Nick said, I'm John Emery. I'm a principal consultant at PH Data, which was formerly known as Tessellation. So today I'm going to talk to you about extracting data from PDFs, both text-based and image-based. And then we're going to talk about regular expressions, which are a very important part of text processing, which frequently comes up with extracting data from PDFs. So like I said, you have a couple of different types of PDFs. You have your text base. Oh, good. Everybody can hear me. So you have your text-based PDF. This is like your typical Adobe Reader type PDF where you can go in there and highlight a piece of text. So if you can go in there and highlight it, you can click and drag on a piece of text. That's text-based. And there's also image-based. These will typically be scans of, say, books, medical records, financial records, those kinds of things. These types of PDFs, you cannot go, like I couldn't go and highlight Penguin Books there at the top because it's just an image. So depending on the type of PDF you have, there's two different ways you can go about extracting the text. And as you'll see, one of these is typically quite a bit easier than the other. So the first that we'll talk about is text-based PDF extraction. And in KNIME, this is typically done with the Tika parser tool. There's also something called the Tika parser from URL tool, which does the exact same thing. The only difference is Tika parser comes from a file source, and then the Tika parser from URL obviously comes from some sort of internet-based source. So the Tika parser, and I'm going to jump over to KNIME real quick. I have a workflow that I have built. I'm going to be using the Tika parser URL input, but all of the configuration settings are identical. So before I get into the workflow here, let's look at the tool itself. So you give it an input. In this case, I'm choosing my URL. If you're using the other Tika parser, this is where you identify a file on your local directory. And as you can see, I have my URL, which is right here, mountainwashington.org, uploads forms, then the date.pdf, and that is a path variable. So then, more importantly, we have our file types. And as you see, this is a very long list. There must be over 100 different file types here for you to choose from. But in our case, we're just going to go ahead and choose PDF. So once you choose your file type, you then have various metadata that you can choose from. File path, MIME type, whatever that is, title, author, contributor, and so on, all the way to the very last one, the actual content of that PDF. And you can hold Control and click to select multiple things. So in this case, I've just selected file path and content. You have a few other options here that we won't really get into. They're not really that important for what we're trying to do. But what you see is, originally I had my dates, blah, 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 I had my URL. And then when I pass it to the Tika parser, you now see that for every single row, 210 rows in this case, I have columns for every one of those file or types that I selected, in this case, file path and content. And then you can see in the content, this is all of the data from the PDF for that particular URL. And if I go ahead and open this up, it'll be kind of hard to see here. But here is that PDF output as a single cell in a table within KNIME. So we have a bunch of header metadata. We have the actual data that we're interested in, right? From this row that starts the line that says day all the way to this line that says 31, and then some other stuff. So I'm going to jump back to the presentation real quick. This is all based on the Apache Tika library, if you're familiar with that. And these slides should be available to you, so you can click on any of these links. And we just saw that. So actually, before I move on, what I really want to show you is this PDF parsing was one tool. all I had to do was either provide the URLs or provide the files, and the Tika parser actually parsed out that PDF. But as we just saw, all of the data was in one line. Clearly, that's not very good for analysis. So if I zoom out, you'll see the rest of this workflow. Everything else here is dedicated to splitting that data out and actually building a table that I can actually use and perform some analysis on. So you can see here, now I have my, as far as I can tell, perfectly split out data. But to get there, I won't go through every step since we don't have time for that. But to get there, I had to use date and time row filters, cell splitters, column renames, column expressions, filters, concatenation, had to change file types or field types, date and time shift for some reason, I don't remember anymore. So I think what you'll find is when you're extracting data from PDFs, the actual parsing is the easy part. It's then splitting that data out into something that's usable is where it could be potentially very, very challenging depending on what the initial PDF is. And in fact, I'm going to go ahead and I'm going to show you what that initial PDF of the URL looks like. So you can get an idea of just, what you're working with. So you start from this. You've got, this table data, but you've got all these different header rows. Some of the header rows take up multiple rows. Then you have all this extra data down at the bottom, like footnotes and stuff. And depending on what your PDF has, if you have a lot of this extra stuff, your work can be very, very challenging. Whereas if your PDF is a very basic table, maybe your job will be very easy. It's going to really depend on what you're trying to do and what your PDF is, and that'll control how challenging this task is. So with all that being said, that's your text-based PDF parsing. The next thing is your image-based PDF extraction, and this one can be even more challenging. And unfortunately, there's not as much that you can do about that. So this uses something called the test4j node, which I believe is I don't remember the name of the extension, but you can search for it easily enough, and there'll be links in the slides for you. But what you're going to find is, if you don't have the slides, I'll make sure you get them. We'll put them in the chat if you don't have them already. So what you're going to find is when you're parsing the data from an image-based PDF, the initial quality of that image is going to determine how well you can actually do extracting the data. For example, in this upper left corner, this is the image that we have. You can barely even tell that it's an image. It just looks like a text box, right? We have a white background with black text on top of it. And using that, go back a slide, using the image reader and the test4j node, I believe the test4j node only works on Windows, but somebody can correct me if I'm wrong there. And so we have this white background with black text, and you see in KNIME, it looks perfect. There is basically no difference from the image to the KNIME text. And then once you have that KNIME output, you can then parse it out like what I just showed you, cell splitters, row splitters, all that kind of stuff to get it into a shape that you can actually use. Now, on the other hand, you've got your low quality image. In this case, you see it looks like a table, and that's great. Unfortunately, the table has a medium or dark gray background. The text isn't solid black. So there's not that big contrast from text to background. And in some cases, that tesseract image or OCR algorithm doesn't do such a good job, as you can see in the bottom left square right here, where you basically get gibberish and it's unusable. There are some like image processing steps that you can try, but in some cases you're just kind of out of luck there, unfortunately. It'd be very dependent on the quality of the image that you're working with. And in those slides that have been share with everybody, you can click on this link right here and actually play around with this workflow to see how it works in practice. So, like I showed you in that workflow earlier, you've extracted data from the PDF. Well, what do you do with it? Well, you can make a table, like what I did with the Mount Washington weather. You can do topic modeling, and we'll see a slide or two about that in a moment here. Or you can actually do some targeted text analysis, like in this snippet of a contract at the bottom, you can see a date. I used to work at a financing company, and we had a thing called probates, which was basically I would have to go through these contracts and figure out when all these probate contracts were signed. And had I had this sort of PDF text extracting ability, my life would have been much, much easier, because as you can see right here, we can actually target that date, August, or it's probably European, June 8th, 2016, and you can actually pull that out of the contract and then perform analysis on it automatically, rather than having to go through one file at a time and pulling out those pieces of text manually. So, like we showed you earlier, I won't spend too much time on this slide. Take your PDF, you parse it using the Tika parser, and then your workflow output is whatever it takes to get from that second image to the third. Maybe it'll be very easy, maybe it'll be very, very challenging or bordering on impossible, but you can always try. There's no guarantees with PDFs, unfortunately. And then again, there's just a snippet of my workflow. As you saw, it goes on for a while. And another link for you there. So topic labeling and topic modeling. So natural language processing, or NLP, is a field of research all into itself. I'm not an expert in it by any means. But one thing that you can do, say you've taken a PDF, you've extracted the data, and now you want to start finding out valuable insights from that data. Like in this snippet right here, we have this data set where every line has some sort of text. We've got typos, we've got periods and commas, we got numbers, all sorts of weird stuff can happen, as anybody that's worked with free-form text can attest to. You never know what you're going to get. So, and we're going to talk more about this in a few minutes. Once you've extracted that, you can use regular expressions to start really pulling out the important pieces of information. For example, in this slide right here, we've used the regex find all, which is a custom component that you can find on KNIME Hub. And we're basically finding where the word crack shows up, where the word material or coding or missing, and then splitting those out into various columns. And we'll look at this workflow in a few minutes. So that's when you know what your labels are. I know that I want to find crack and material and vibration. But what if you don't know? In that case, and again, this is far more complex than we have time to get into, you can use the topic extractor node, parallel LDA, which I think is latent Dirichlet analysis. Ooh, I'm reaching on that one. It's something like that. But what this does is it allows you to assign topics, which is a vague term in this case. It assigns some sort of numeric value to these words. And then what we've done here is made a word cloud. And we'll see that also in a minute here when I show you the workflows. And in fact, let's go and do that right now before we move on to our topic on regular expressions. So in this workflow, you can think of this like a dictionary file. All the words that we're interested in finding in the PDF or whatever text we're looking at. Do some basic text processing, make it lowercase, which is typically a safe thing to do. And then in this group by node, we've used the concatenation aggregation with a delimiter of a pipe. And as we'll see in a minute, a pipe in regular expressions has a specific meaning, and it means or. So this group by has made this text string right here, crack, pipe, material, pipe, and so on. And what that's going to mean is we want to find the word crack, or the word material, or the word missing, and so on in whatever text. We turn that into a flow variable, and then pass it into this custom component called regex find all. And the data that we're passing in that is that text that we've either pulled from PDF or comes from wherever. It doesn't really matter. So you can see here we have all of our text. I guess these are comments on some sort of, I don't know, some sort of thing. Again, we make it all lowercase because regex is case sensitive. So you need to be careful of that. And in this regex find all, you type in some input, but we're actually passing that flow variable. So instead of crack, it's that long concatenation that we saw. And you can see what it does is it gives us this output right here. And so this is a collection field type. So you can see this first one had the word crack, so it finds the word crack. This fifth line right here, it found the word missing and the word coding, so your collection has 2 elements. I don't think there's any with 3, but you get the idea. And then from there, you can use something like the split collection column to make individual columns for every element that you see. So if one of those collections had 3 elements, we would have 3 columns and so on. And from there, you can do whatever analysis you need to do. So then we'll just very quickly look at this. We won't get into details, but here we can look at this Tika parser again. We've got this KNIME workflow data books directory. And you see this time, instead of a PDF, we're actually parsing an EPUB, which I believe is an ebook type of document or file type. We've selected all of the metadata columns here from file path all the way down to content. And you can see, if I just quickly scroll through here, we got our file path, MIME type, title, author, all the way down to content, which is the Project Gutenberg e-text of Romeo and Juliet. So that will be the entire text of that play. Our table creator won't go into depth. These are just things that we're interested in finding. Do some pre-processing, pass it through this topic extractor. But then what I want to show you is this word cloud. And now you can see, I'm not exactly sure what these mean because I didn't study the node right there. But you see we have different colors, which I'm assuming are the different topics. And the size of the words are presumably how frequently those words show up in the play. But in this case, we didn't pre-program anything. We didn't say we want to find this list of words. This algorithm found those topics based on however this algorithm works. So let's go back to the slide, and I'm going to wrap up the presentation with a talk on regular expressions. I work as a consultant, so I talk to clients from various industries every day. I mentor our younger consultants, and I always tell them, learn regular expressions. You don't need to be an expert by any means. Like I do it almost every day, and I still have to Google things frequently myself. But just knowing what regular expressions are and what they can do for you and how to write just basic ones will go such a long way for you as an analyst or consultant. I really can't overstate it enough. So let's look at this. We have 3 different dates: year dash 1-digit month dash 2-digit day. We've got month, 1-digit month slash 1-digit day slash 4-digit year. And then 2-digit month period, 2-digit day period, 4-digit year. So 3 dates. We can all read them, no problem. But KNIME has a specific type of date that it needs. It needs your 4-digit month or 4-digit year, then the 2-digit month, then the 2-digit day to actually learn it as a date. So what do we do with this? Well, we can use regular expressions. So regular expressions allow you to write some sort of expression that we'll see in a moment, search through text, find a pattern, and then either identify if there's a match, replace, find things, split things, parse things, tokenize things. They're incredibly robust. And I use this all the time. Anybody that's used Excel knows, your left, your right, your mid. Those are great. But if you have really complex data, your functions or your expressions using those things are going to get very, very complex very quickly. With regular expressions, you can have like a more fine-tooth look at the specific pattern that you need. So let's look at some examples. So this first date, 4-digit year, dash 1-digit month, dash 2-digit day. And then what you see at the bottom there is your regular expression. Oops. So initially, a regular expression is going to look like absolute gibberish, but it's not that bad once you know a few special characters. So we've got in brackets 0-9. So the brackets create, I can't remember the exact term, a character class. Thank you. Character classes. So what this means is 0-9 in bracket means I want to match with any digit character 0 through 9. Inside of the squiggly braces tells us how many of those preceding things we want to match with. So in this case, we want to match 4-digit characters, not 1, not 2, not 3, not 5, but exactly 4. Then you see we have the little dash icon right there. That is a literal dash. So in this regular expression, we have to have 4 digits, then a dash. Then you see here we have 1, 2. That means that we can have 1 or 2-digit characters. Then we have another literal dash, and then another set of 1 or 2-digit characters. And we're going to see some examples in practice of this in a moment. So a very quick cheat sheet here. There's a lot about regular expressions that you could do plenty of searching online on your own. There's various characters in regular expressions that have special meaning. A period represents any single character. So in this case, we have the regular expression capital F dot lowercase r. So that could match with the word for, far, but it would not match with the word for, F-O-R-E, for example, or for F-O-U-R, because the period only represents one character in between the F and the R. You have characters like the plus sign, which represents one or more of the preceding things, and the asterisk, which represents 0 or more of the preceding things. So in this example, we have our character class 0 through 9 with a plus sign after it, means that we want to match with 1 or more digit characters. So like 77, 9, 123. This would not match with 0.9 or 1.5. You would have to write something more complex for that. Our letters, so we've seen the digit character class 0-9. Well, we can also write character classes for letters with A-Z in lowercase or A-Z in uppercase. In this case, we've done them both, and this will match with any lowercase or uppercase letter. You can also, say you don't want to match A to Z, say you only want to match A to D. Well, you could write A-D, and regular expressions are smart enough to know only to match with A, B, C, or D, and nothing beyond that. And you can also put in your digit characters 0-9. In fact, you can put anything you want inside of brackets, and that becomes part of your character class. So like we mentioned earlier, the pipe represents an OR operator. So in this example, we want to match with 4-digit characters or 2-digit characters. So 3-digit characters would be not matched with. Then we also have parentheses, which we haven't talked about yet. Parentheses create what are known as capture groups. We're going to see this in a moment, but here we have 3 capture groups. So a period and an asterisk next to one another creates what's known as a greedy match. So basically it matches everything. So we have our match, and then we have our 4-digit characters, and then match anything. So this example is anything up until our 4 digits, and then anything beyond that. So let's go ahead and look at some of these examples. I think I've got about 7 or 8 more minutes left here. We should have plenty of time to wrap this up. So we've got a simple data set right here. Product labels with some weird text strings. So there's in KNIME a number of ways that you can use regular expressions. And there's a number of things that you can do with regular expressions depending on what you need to do. So let's start and look at the rule engine right here. Then the first thing, let's look at the output. So we want to do a match. What matching means is you want to create some sort of flag. Typically, this will be a Boolean type field like match versus doesn't match, 0 versus 1, true versus false, that kind of thing. And you can see right here, our first 2 and the 4th row match, and the 3rd one is missing. So how do we do that? In the rule engine, there is a function called matches. And if you read the description for it, matches uses regular expressions. So we have our product label, matches, and then inside of quotations, we have our regular expression right here. Period, asterisk, so again, your greedy match. Our 0 to 9 character class, 4 digits, and then another lazy or greedy match. So basically, does the value for product label have a set of 4-digit characters in a row with anything before it or anything after it? We don't care what that stuff is, as long as there's 4 digits in a row. And so you can see here, well, the first one has 5 digits. So there's 4 digits within 5, so that's good. The second one has 4 digits, so it matches. The third one has nothing, so it doesn't match. And this last one has a set of 4 digits, and then a second set of 4 digits. Well, that doesn't matter because all we care is that there is a set of 4 digits somewhere. And just to show you real quick, I'm going to go into this table creator. And I'm going to change this. I'm going to add 3 digits. And you will see that it still doesn't match because we have to have 4 in a row right there. Okay, so you can use the rule engine. The rule engine is good because it allows you to dictate what your output is. In this case, we say match, but I can just as easily say I want that to be a 1 and then the else as a 0. And now we have a nice binary Boolean field. So on the other hand, you could use the string manipulation. Inside the string manipulation node, you have a function called regex matcher. It does the exact same thing. And we're matching with the product label. And then here we have the exact same regular expression. The only difference is now you can't dictate what that output is. It's either true or it's false. And that's the end of it, which is what you can see right here. Logically, it's identical, but you don't have that flexibility in the output. So the next thing we'll talk about is regex replacing. So in this case, we're going to use, again, the regex replace function, which applies a regular expression to a string and replaces the string if the regular expression matches. So here, we're going to match with our 4 digits, and we're going to replace it with an empty string. So you see here on this first one, we had a 5 digits in a row. And you see, we've replaced the 1, 2, 3, 4 with nothing, but we have the 5 left over. The regular expression, unless you denote that you want to do something different, is going to take the first 4 digits that it finds and replace those, which is why the 5 is left over. But interestingly, if I go in here and I add 6, 7, 8, so now we have 2 sets of 4. What do you think is going to happen? They both get replaced. So it finds that first set of 4, and then it finds the second set of 4, and it replaces them both. So just keep that in mind. That is a thing that can happen if you're not careful. But you see, like down here, because the 5555 and the 66666 were separated with a period, they both get replaced because they were not one big string, but rather two separate 4-digit strings. So regex extracting, using the same function that regex replace, you can add a third parameter here. So it's the exact same idea, but now you see our regular expression is different. We're using those capture groups. So in the first capture group, we're saying match anything. In the second capture group, we're again matching those 4 digits. And then our third capture group is match anything that comes after it. This new parameter now, we're using this $ operator. The $ allows you to pull out one of the capture groups. So $2 means I want to extract the second capture group. $1, extract the first capture group. $3, extract the third, and so on. So when we look at this, we see now, oh, I think I messed the original text up. I need that. I want that 5 back in there. So let's look at this. We have now extracted 2, 3, 4, 5. Why didn't we extract 1, 2, 3, 4? That is the difference between greedy searching and lazy searching. If I'm not going to explain the details of this. If I put a question mark right here, this is now a lazy search. And if I run it again, I get the 1, 2, 3, 4. So that's something that if you want to learn regular expressions, that you will have to be familiar with is what these two different search types are and why you would use one in a situation versus another. It'll be the difference between getting something right and not getting it right. But you see, we've simply extracted those 4-digit patterns from each of these columns or each of these rows. You can also do that using the column expressions node. The difference here is column expressions uses the JavaScript language. So if you're familiar with JavaScript, you can go ahead and use this and just write whatever function you want. I'm not a JavaScript person. This isn't something that I would do personally, but it's an option for you if you desire. And the regular expressions in JavaScript are written a little differently, so I won't get into details there because, frankly, I don't know the details. But you can see the outputs will be the same. And finally, we can use that custom node or component regex find all. In this case, we want to match with one or more digit characters. So this one is extracting every set of contiguous digit characters. So you see, like in this bottom one, we have that period separating the 5s and the 6s. So we get this collection with 2 different elements, which can then be tokenized or split out. Okay. You can also filter both columns and rows with regular expressions. I actually just did this today. In your column filter, 9 times out of 10, you're going to use the manual selection. But sometimes you don't know the columns that might show up. Like I was doing like this recursive looping, and depending on what was going on, I didn't know what columns may or may not appear. But I had to account for that. So you can go here and write a regular expression that will match columns, and then you can exclude them or exclude them or whatever. And that way you're getting a dynamic column selection based on this regular expression. Likewise, in the row filter, in your matching criteria, you can write a regular expression. You see here we have that same one that we've seen a number of times. Make sure to check the regular expression box. And you can see we've matched with all of the product labels that have a 4-digit number, and we've excluded those that do not. And finally, we have the regex split node, which allows you to split kind of like this 2-column or this 2-node sequence right here, but allows you to split data or text based on a regular expression. In this case, we've said we want to split the product labels field. So we're going to match whatever. And right here, \period. So as we saw earlier, the period represents any single character in regular expressions. So whenever you want to match with something that has a specific meaning in regular expressions, you have to do what's called escaping it. So this \ is your escape character. So this means I want to match with whatever until I get to a period and then match with whatever. And notice that we're doing greedy matches on both of these again. So that's actually matching with the last period, which you can see right there on this last row right here. You know, we have a period in split 0, and we split it on the last period. And so if I go in here and I put a question mark in and run it, we're now splitting it on the first period. The difficulty comes on what if there's like 10 periods and you want to split on the 6th one? Well, that's a little more challenging, but hopefully you get the idea. Regular expressions, really, really, really powerful. And then in the slides, just getting back to the slides, if you want to learn more about extracting data from PDFs, you can go to this link, and that's all I have. Hopefully that was helpful for everybody. I will stop sharing my screen now, and I'll get out of the way.
Okay, thank you, John. Let's share screen. All right, so I just want to be sure everyone can see my screen. I will give a brief talk on what we do with our data once we have captured it. All right, so I think everyone can see the screen. I think everyone can hear me. If not, please post and we will see that. So what we did so far was extract data from our PDFs. And then from there, we want to say, well, what if these PDFs are a little bit weird or odd, or maybe they're outliers? And so what we want to do is find points or PDFs which are different from the rest of the PDFs in some way. This is really outlier detection. So you have, for instance, a database with millions of PDFs, and they have investment agreement numbers, they have the amount of payment that was made, they even have the date, for instance. And you want to look through and say, which of these have kind of suspicious amounts? Maybe you're paying too much or paying too little, or maybe someone is pulling some kind of fraud on you. So we want to figure that out with these PDFs. So we go in, we perform our PDF extraction like John showed you using regex, for example. We get the payment, we get the contract ID or the contract date, etc. From there, we can perform three main techniques for outlier detection, such as visualization, statistics, and machine learning. So we'll walk through those briefly. With visualization in KNIME, it's really simple to create a nice dashboard by simply having visualization nodes such as a bar chart, a scatter plot, a box plot, a histogram. Just put them together, wrap them in a component, and you can generate a visualization, such as this. And we can see quickly where there are points that are a little bit suspicious, right? This one goes a little bit too far. This box plot already indicates this is an outlier. And over here in the scatter plot, I can quickly identify the points that just stand out. Oh, let me see the chat. Perfect. Okay. Now, for visualizations, the great thing about them is that they're aesthetically pleasing, and you can spot outliers easily if your data is small. But on the con side, we're going to have to investigate we're going to only be able to investigate 1 or 2 dimensions at a time, right? I'm only going to be able to see an X and a Y axis. Well, sometimes you can add the Z axis, but it gets complicated there. And this is really manual checking. And once you've checked and decided this is an outlier, then you're going to have to select that manually and then explore it further. So we want to move past the manual process. We want to do it more automated. To do that, we might use statistics. For instance, some of you may be familiar with the interquantile range. And I won't bore you with the details here. Instead, I will leave these slides for you. But for the IQR technique, we can actually implement this easily using numeric outliers. So for numeric outliers, we simply tell the node what we think is going to be an outlied item. And then we can generate some nice graphics, for instance, or If we use the tile view, it can actually just show us the items that were considered to be outlier points, those with really high payments, for instance. We can also use the z-score technique. And this technique, again, I'll leave the details here for you. But in KNIME, this is really simple. I simply say, I want to normalize my data, create a z-score, and then I want to set some threshold. I want to say, is the z-score greater than some number? And then we will classify anything greater than that threshold as an outlier. And so really, this is just two nodes. This is a z-score using the normalizer node, and the rule engine saying, is it greater than or less than? Okay, now I will do a summary and then I'll check the comments. So for the pros, we have extraction automation, which is really easy to understand, right, with these statistics, as long as you get the IQR or the z-score technique. And it's just one or two nodes for the most part. Now the cons, though, is that you might need to know some stats, and your data might be forced into a normal or Gaussian distribution. And again, for the techniques that I'm showing, it was really unidimensional analysis, just looking at one thing at a time, which could be a little bit problematic. So we want to talk about multidimensional analysis. So let's see here. People, can everyone please mute their lines? Is everyone able to hear me? Okay, seems like this may be one person. All right, so let's continue. So if we're looking at one feature or many features, for instance, let's say there is data on salary and hours worked. Perfect. On salary and hours worked, we can say here that there is an employee who works very few hours, but for some reason has a very high salary. And for you and I, we notice right away that that's a little weird. How can someone do that? But if I look on a unidimensional space and I just look at salary or I just look at hours worked, this employee doesn't stand out anymore. Their salary isn't high enough to be considered an outlier based on this data, and the hours worked isn't small enough to be seen as something weird. So that's why I needed two dimensions in order to figure out that this person could be a little bit suspicious. So unidimensional space, some outliers might not be able to be seen, but we recommend beginning with a multidimensional outlier detection first, and then progress to the one-dimensional space to check for outliers. How would we do that? Well, we could use machine learning. For instance, you might know about these two algorithms specifically for outlier detection, such as the isolation forest or a DB scan. Now, today we're going to skip over the details of how these algorithms work, and I'm just going to show you how to implement them in KNIME. Later on in the beginner's corner, if you want to talk a little bit about this, we can go over those slides, but if not, feel free to download them and then look at how I explain them. So how do we do these in KNIME? So the isolation forest requires a learn and predict motif, which you may be familiar with if you've done machine learning in KNIME. If not, we simply take the data in, we learn about the data, that is, we model the data, and we create something that can predict for us. Then we predict on the data, and we say, is this an outlier or not? Then we can do some kind of evaluation, for instance, setting some threshold where we say, if it's greater than some percent or some number, we're going to call it an outlier. And so this is how you would set up the isolation forest in KNIME. And you can download this workflow via the links in the slides. And once you've done that, you can then create the same kind of visualizations we made earlier using the statistics. Now, in terms of DB scan, for instance, we have a table reader node, a normalizer, which is what we used earlier for the statistics part. We also have numeric distances, which is important for the DB scan as it requires some kind of numeric calculation or numeric distance in order to compute the outliers or the noise points. And then DB scan. So you see here this is quite simple comparatively. It only requires 4 nodes versus the isolation forest, which requires a bit more work to get working. And again, we can generate the same kind of graphics and potentially different outliers. So we'll leave the details here. Instead, what I'd like to do is actually show you in KNIME how this would work. Let's see the comments. Yes, you can download, if everyone can see my screen at the moment, you can download the slides here where it says slides to the right of where I'm standing currently. Okay, let's look at KNIME next. So what I've showed you so far was different ways in order to visualize your outliers. We can take, for instance, the Tika parser or the PDF parser. The PDF parser specifically deals with PDFs, so it's a little bit more manageable, easier to look at. We simply specify where our data is, and KNIME will then go ahead using this node and get all of the PDFs that you have in this folder. So if I click on my output, I can see now that I have a document type which contains all the text from the different PDFs. From there, I can use the regex that we learned earlier in order to extract the data. So for instance, I can extract from each of these PDFs the contract ID, the date, and the payment. From there, I can perform those different techniques that I talked about, such as building a dashboard. Here you can see our dashboard at work with a bar chart, a histogram, a box plot, and a scatter plot. And creating this is quite simple. I simply need to put nodes together inside of a component. And creating a component in KNIME is as simple as collecting a group of nodes and saying create component. And then voila, we have a dashboard. We can also go ahead and use statistics. So you can do numeric outliers and simply specify what will be your K value. You can use the normalization and then use that z-score method that we talked about. We can also do dbScan, which is that simple 4-step method. And here I've added just a little bit of creativity in order to allow us to click on the outside of my node. So you can see here I'm able to modify different parameters of this algorithm. So if you're familiar with machine learning, this will make sense. If not, don't worry about it. This is just for those people who are interested in kind of getting a sneak peek at how we do things here. And then we can visualize. So we can see what this algorithm is saying is an outlier, for instance. And you can do the same thing with the H2O isolation forest. So we see here that same workflow that I showed earlier with a bit of extra bells and whistles in order to make it easier for the user in order to use this workflow. Okay, so we quickly went over how to deal with that data that John showed us how to get from our PDFs. And that will be the end of this section. Next, what we'll be doing is going over the parts where we will talk about, for instance, an intro to, let's see here, an intro to the beginner's corner. Well, I will be showing anyone who wants to learn a KNIME for the first time, how do we get started in KNIME, how do you use it for data preprocessing, machine learning, things like that. So if you want to join me for that, please go right ahead. As well, we'll also have networking for an hour after this. And please remember, on the beach, you can go to the KNIME library and you can get many, many free books. And some of them relate to the topic that we've talked about today. For instance, From Words to Wisdom will teach you a lot about processing textual data. Okay, and then there's also more articles that we can download. So please grab these slides. And if not, we will send them to you in an email. Okay, thanks everyone. And I will see you at the beginner's corner on the beach.